Hello everyone, myself Pragati Jakatimat, and today I am explaining the assignment 1 of CML661. Here I am gonna identify the point groups of sample crystals given in the class. Here we can see two images. Figure 1 represents the number of given crystals and figure 2 is the crystal chosen for study. Now let's analyze the morphology to identify its point group. The crystal appears to be perfectly cubic with all edges equal and all faces identical. Each face meets the other at right angles, indicating high degree of symmetry. Such features are typical of crystals belonging to the cubic or isometric system. In the cubic system, crystals are equidimensional. That means all the three axes are equal in length and perpendicular to each other. The crystal looks identical from every direction. There is no stretching or squashing along any axis. So the shape is perfectly balanced. In other words, the crystal doesn't look elongated or distorted. Every face and edge has equal proportions. The crystal has mirror planes along the x, y and z direction, which means if you cut the crystal through the middle along these axes, both halves would look like mirror images. It also has four threefold axes of rotation passing through the body diagonals. That means if you rotate the crystal by 120 degrees around these diagonals, the shape looks exactly the same again. This shows the high symmetry of the crystal structure. So in this slide, first we look at the possible crystal system, which here is the cubic or isometric system. Next, the most probable point group for this type of crystal is M3M, also written as octahedral. This point group represents the highest level of symmetry, the cubic system. It includes mirror planes, rotation axis, and a center of inversion. Finally, this kind of symmetry is commonly seen in ionic crystals. This slide gives the justification for identifying the cubic crystal as belonging to the M3M or octahedral point group. First, the equal edges and identical faces of a cube indicate very high level of symmetry. Every face looks the same, which is a key characteristic of cubic crystals. Next, the presence of several mirror planes and rotation axis matches perfectly with the symmetry elements of the M3M point group, which has the highest symmetry among all the cubic systems. Finally, since there is no elongation or distortion in the structure, it can't belong to the tetragonal or orthorhombic systems. That's why the cubic M3M point group is the most accurate classification.